Hi class. I'm going to walk you through making this phone holder again from scratch. This time, just to make things easier, we're going to do the parameters first. So go ahead and open the parameters menu, which is again under modify and then the FX. And we're going to push this plus sign to make a new parameter. And one by one, we're going to add all these parameters. And for the sake of making the video easy, just go ahead and make your numbers the same and your names the same as mine, or more or less the same. You can also rename them later, like for example, like maybe this E should be lowercase, and I guess to be consistent, I should finish all the words. And it will actually fix it. It won't break any of your links. So you push plus to add a new one. All of them are in millimeters except for the first one, phone angle, which you actually have to change the unit to degrees. So mine I have to just say phone angle 2, but just because I can't do it twice. And then for now we're going to do 70 degrees. But I'm going to click cancel because I already have mine. So phone angle is going to be the angle the phone rests at, and that's measured from behind the phone. So between the horizontal plane and the phone, from behind the phone, not in front of the phone. Thickness of the material, we're going to start with 3 millimeters, which is about 1/8 of an inch. The bottom length is the size of this panel here, between there and there. The kickstand length we are calculating using trigonometry, which you don't really need to worry about, but in order to calculate how long this is, based on how long this is and this angle here, we're going to use this formula, which is TAN, stands for tangent, and then begin parenthesis, of phone angle, end parenthesis, times bottom length. And that will probably be red until it's not. Yeah. Thickness, the slot width is in our model. We're going to just use the thickness for the slot width, but sometimes you might want the slot width to be a little bit narrower or a little bit thicker than your material, and it's nice to have it broken out as a separate parameter. Phone width, I have 120 millimeters. So the width of the stand is going to be the phone width plus the extra width. And then extra height and phone height and phone ledge, which is the size of this little shelf here where the phone lives. So you can just pause the video here to copy this. I also included comments, and I'm including this file on iLearn. So in order to make it so I don't have to make my parameters again, I'm going to just delete my whole file. And there's a couple ways I could do that, but I like to use the timeline. First thing I can do is I'm going to save it, so I can say about to delete all except parameters. That way, if I decide that this was a mistake later, I can recover it and easily know. The way I'm going to delete my file, which again you don't have to do because you're starting from scratch, is I'm going to drag back the history marker, which lets me actually go back in time through all the steps, when we made the plane and so on. After I go back, I'm going to say delete all features after history marker. And if I go back into parameters, you see I still have my parameters, but I have nothing else. It's a totally empty model. And rule number 1 for Fusion, according to the Fusion community and according to me, is always work inside a component. component. So if I were to just create a quick sketch and do something, it's going to do something we don't like, which is going to put the sketch here. So I'm going to do Control Z, and that's going to disappear. What I'd much rather do is work inside of a component. And the way you do that is you go Create, New Component, Empty Component, and we're going to call this Back. Back is fine, but you can be like, back a phone holder or whatever you want to call it. And you see this checkbox here, which is Activate. And this is just saying that after I create it, I want to be working inside of it, and we want that checked. Parent is just saying where is this component going to live, and it only has one option right now, which is to live at the top level, to live in the file. Sheet metal components, we don't learn in this class, but they're kind of cool. If you want to look into that, you can Google it, but it lets you make things to be folded out of sheet metal or other materials. So now that I click OK, you see that instead of working here with Rob's third phone holder V3 activated, I'm working here. Back is activated, which is what we want. The next thing I'm going to do is I'm going to click Construct Plane. I'm going to click Plane and Angle, and then I'm going to click this axis. It's come to my attention that my axes are different than yours. I think that might be a setting I have. But you want to click the axis that lives underneath front. And then you want to rotate it this way. And replace this number with phone angle. And the reason I moved it first is just to make sure that it's going in the right direction. And because some other people, it seemed, had this issue where their angle got weird. Once we create that plane, it's going to hide the origin planes. These origin planes, because it thinks it's right in thinking that we don't need them anymore. Now that we've created that plane, and again that was under Construct Plane and Angle, we now have a plane that we can work on that is not one of the planes that comes with Fusion. And you can see that if I open my parameters and change this to 45 degrees, the plane moves, but I'm going to move it to 70 degrees. Now I'm going to create a sketch, and again we still have back activated, so both that plane and that sketch live inside of back, which is ideal. And I'm going to click that plane. Now I'm going to draw a rectangle from the origin, which is this symbol here. From the origin, just anywhere, and just click. You can type numbers in this box, but it's not as fun. And then using sketch dimension, which you can either get by clicking here or just pushing the D key, I'm going to draw a dimension on this line, and this is the hardest one in the whole class. So this is, this whole exercise. This is bottom length plus slot width plus phone height plus extra height. And you should get 95.7. And the reason there's a decimal is because I made one of the things in inches. And then for this line here, the horizontal line, we're just going to do, this one's easier, phone width plus extra width. Then enter. And you can see that now all these lines are black, and that means that they're fully dimensioned, they're fully constrained. They cannot move because we've given them no ability to move. Since our first corner was defined as being at the origin, and we defined it as a rectangle, and it cannot rotate and it cannot change size or shape. The next thing we're going to do is make another rectangle starting from the wall and just going anywhere. In this video, we can do it a little differently than last time or the same way. The first thing I'm going to do is I'm going to take that line and I'm going to do slot width, and then I'm going to do this line to here, and I'm going to do bottom height, bottom length. And the last thing that's blue, you can see this line here is blue. And the reason this line is blue is because I can move it. Anything that can be moved in the sketch environment is blue. But we want this to be at exactly the midpoint of this. And the way we did it last time was with a dimension. And then I clicked, but instead of typing, I just clicked here and said, I want to reference that dimension. And you can see that it calls it dimension 32. And then you can do math with that dimension. You can say divided by 2. And just like this is 140, but this is 70. Another way to do it, which I'm just going to show you just because it's a learning opportunity, is to go back to the line tool. And if I start drawing with the line tool, you can see that I get a solid line. But if I start drawing with, if I'm about to draw with the line tool and I check this construction box here, what you get is you get a dotted line. So I'm going to check that box. And you can see the line is dotted. And the difference between construction lines and regular lines is that construction lines don't make regions. So you can't extrude your construction lines, which is really useful if you don't want to. For example, this one can be extruded. You can do anything with it. It's real geometry. The construction lines are only used for construction. I'll show you what I mean. So I'm going to make a line. I'm going to check the construction box. I'm going to make this line between here and here. And you see these little triangles where the line begins. You might notice the same triangle in the constraint window. Because I clicked near the midpoint, it assumed that I want it to be exactly on the midpoint and made that constraint for me. So some constraints are automatic. Just to give a quick example, I'm going to make another one here that's just in a random spot. And you see this one isn't constrained. I can move it around because I didn't make it near the midpoint. And you can actually select that line and turn it back into a regular line or back into a construction line. But I'm going to make it into a regular line just to talk more about the difference between construction lines and regular lines. I'm going to finish the sketch. I'm going to bring up the extrude menu. And you can see here I can extrude on either side or both sides of that line. But you see that it ignores the construction line. It doesn't cut that region in half. Like this line cuts the box in two, this line does not. I can go back into the sketch. Oops. I'm going to delete this line because it was just for example. And then you can make a constraint between this entity and this entity. And if you select both lines, you have to use the collinear constraint because that's the only. But if a different way to do it would be to select a point on the line and then to do the coincident restraint. Oh, sorry, I'm doing it the way. Click coincident, click a point, and then click the line. Or click collinear, click a line, and then click a line. And that's the same as what we did before with the dimension. It's just a different way of thinking. Whether you want to construct things with geometry or with math. Great. So now this sketch is complete. To review, the width is phone width plus extra width because we want it to be the width of the phone and then any extra for aesthetics and ease of use. The height is bottom length plus slot width plus phone height plus extra height because we want it to be the height of the bottom plus the slight height of the slot plus the height of the phone plus the extra height. This is the slot width because it's the slot, and this is the bottom height because it's the bottom. Now I'm going to click Finish Sketch, and I'm going to extrude away from the ground. So I'm going to click Extrude, then I'm going to click this, and I'm going to type thickness, and then I'm going to push Enter again. And now you see that we have a really clean file. You know, if I close the back folder, everything about the back is included in the back. And again, if we open parameters just to prove that they're working, and we make this 45 degrees, and we make the thickness 20 millimeters, you can see that the file still works. I can change this back to 3 and change this to 70, I think it was. So yeah, now we have we've completed the back component. So now I'm going to go back to the top level, which I've called Rob's third phone holder, and I'm going to activate that. And the reason why I'm activating that is because when I create the next component, what I call this shelf, I want it to be in that folder and not anywhere else. Now you see we have the shelf component, and because the back component is no longer activated, it's ghosted. The next thing we're going to do is we're going to create a sketch, not on any of these 3 planes, and not on the plane that we constructed before, but instead, oops, it's kind of hard to see when it's ghosted, but on this plane here, which is the bottom of the slot. And when I click this plane, it does 2 things. It makes a sketch on the plane, but also this rectangular region that's currently highlighted in slightly lighter gray is going to be projected onto the sketch. What I mean by that is that these lines were just created. Because before they weren't lines, they were part of a 3D object, but now they're in our sketch. But we want more than that to be projected. We want to project the entire top of the rectangle. So I'm going to click here, and then I'm going to click OK. And now you see that we've that was what I clicked, this top of the rectangle. Now you see that we have more lines. We have essentially the entire geometry of the piece. The learning more about project is very useful, and it's a little bit confusing, but essentially what it does is it takes things that are not on your sketch plane and swoops them down onto the sketch plane so you can reference them. The next thing we're going to do is we're going to draw a big rectangle across the whole thing. And then we're going to start constraining it. I'm going to click the Collinear button, and then I'm going to click this line, and I'm going to zoom in a little bit and click this line. And then I still have the Collinear tool activated, so I can say I want this one to be collinear with this one. Great. I'm done with these constraints. I'm going to tap Escape to leave the Collinear tool. And you notice that as soon as I tap Escape, my cursor changes into a regular cursor. The Escape is a really useful tool because otherwise it's kind of easy to get lost. Then we're going to add some dimensions. On the bottom, we're going to dimension this one to be kickstand length. And on the top, we're going to dimension this one to be ledge, phone ledge. And the reason for that is because the kickstand is what I've named the part of the stand that goes behind, and the ledge is what lives on the phone. And we don't need to dimension the slot width this time because it is projected, and projected things can't be changed. See, for example, if I try to put a dimension here, it'll tell me I can't because those are already constrained by the thickness of the piece we projected. So now I'm going to go ahead and finish the sketch. And I'm going to make, it's kind of confusing right now, so I'm going to actually make the back component invisible by checking this little eye. Oops. So it's invisible. And it's weird that that line isn't visible, but it's clearly there. But I guess that's a bug. Now I'm going to extrude. I'm going to extrude this piece, and this piece. And the reason why I picked this piece and not this piece is because I want it to fill in the void created by the other piece, and I don't want to have something, two things in the same place at the same time. Then I extrude that by thickness. Activate the main category. And now if I bring up the parameters menu, I'm just going to resize a little bit so that you can see it's like, okay, what if I want to have a phone stand that works the other way, I can say the phone width is 60 and the phone height is 120. And now I have a phone stand for, like portrait orientation. But now maybe the angle is no good. Maybe now I want 85. No. 80. 78. And maybe I actually don't want to put a phone on this, but I want to put something that's really thick, like a, I don't know, like a cassette tape or something. No, that's too thick. 15. And if I want the bottom ledge to be bigger, I can make this instead of 1/2 inch, which is 12 millimeters. You can see it did the conversion for you between the expression and the value. Instead of making this 1/2 inch, I want this to be 30 millimeters. That works too. And if I measured my material and I found my material to be 15 millimeters, now we have like a really beefy phone stand. But yeah, you should be able to mess with parameters and still have things work. Oh, that's good to know. Control-Z undoes all your parameter changes, not just the most recent one, or all the ones you did while this window was open. So I'm going to save this file as screencast for class, and I'm going to then export this file by right-clicking on the name here and clicking export. I think you can also do it at file export, but the nice thing about right-clicking here is because it's a good habit to get into, because then you can also export components in the same way. But I want to export the whole thing, and it brings up this window. From screencast. And I'm going to save this to my computer as an F3D file. There are a lot of options here. The Fusion file is going to be the only one that includes things like your parameters and your sketches. These other files are great for putting things into SolidWorks or Inventor or Rhino, or if you wanted to get a quote from a factory, they won't have Fusion, or they might not have Fusion, but they'll definitely, these files are like agnostic. They're like the JPEG of CAD. But I want to use a Fusion F3D file. I'm going to save it to my computer. I'm going to put it in DES.460, week 1, phone holder. And then I'm going to click export. And I will put this file on iLearn. The other thing that we talked about was, if you want to check to see if you made a mistake, you can do inspect interference, click the two things, and then click compute. And no interference detected looks like an error, but actually it's good news, because an interference is like this. You see these two things. If I go to display settings, visual style wireframe, no, that doesn't really help. But you can imagine that they're in the same place at the same time. Display settings, visual style, shaded with visible edges only. I'm going to go ahead and click capture position, because otherwise when I do inspect interference, it'll give me this pop-up, and it's just like, do you want to continue or do you want to capture? And if you do continue, it'll snap things back, and usually that's what you want, but this time I actually want to capture just so I can show you that it's wrong. And it'll be like, oh, 1,050 millimeters cubed of volume are in common between these two things, and that's a big problem. Because you can't manufacture something this way. But if I hit cancel and then Control Z, yeah. So that's our project. You might notice that both of these things are kind of loose. I'm going to quickly talk about now, just because next lesson when we talk about joints, it will be good to have it in a video. So what you can do to lock things in place is you can actually ground a component. If you right-click it and select ground, it means it's something that's rigid, that's not going to be moving around. And even it can be moved around by parameters, but it won't be moved around just by your mouse. And it's usually good practice to have one grounded component, to pick something that's like the main component and ground it. But that doesn't solve the problem with this one. And because this one is parametric, we probably could just ground both of them and have that work. But that's not usually what you do. I just want to make sure that's true. Yeah, it is true. But I don't want to do that, because I'm going to unground it by right-clicking and clicking unground. And then I'm going to go into the assemble place, the assemble menu. And instead of clicking joint, joints are great for, what a great example. If you have this complicated machine and you've modeled things that aren't in the right spot, or you've imported a bunch of parts and you want to move them together and have them be related to each other, joint is a great tool to use. But like in our case, if you've built something the right way and you just want to define this relationship, you can use as built joint. So I'm going to select, it's asking me to select the components on this menu. Remember, most tools are going to have this pop-up here, and this pop-up has everything in it. It's really important that this isn't collapsed. I'm going to select this component and then this component. And then you get to select what kind of joint. Now rigid is easy. Rigid is just these two things aren't going to move. And there's all these fun, there's like a ball, and you got to pick a point. And I'll just like, whoa, no, we don't want that one. That's not right. What I want is slider. So I'm going to select slider, and then for position, you just have to select something that is related to the way you want it to slide. So I'm going to click this line, and then I'm going to click it again to say which part of the line I want to use. You can also just click once if you click in the right spot, but sometimes that's harder. Great. So now it's moving in the way that makes sense to me. And if you click animate, you can see the way in which it's moving. But now I want to do one more thing, because I don't like that it can move this way, and I don't like that it doesn't snap back into place. So I'm going to click revert, and I'm going to open the joints menu. I'm going to right click slider, edit joint limits. I'm going to check minimum, maximum, and rest. And then for maximum, I'm going to set this to phone width plus extra width. And you don't have to use parameters for this, because it's it's just for visualization purposes. But the reason why it's nice to is because it will continue to be accurate even after even after you change the parameters. Now I'm going to click OK. And because I used the rest command, the rest thing, it's going to always want to be in that position. But it's nice to be able to show people your model. That's just a bonus thing. We'll talk more about joints later, but I thought I'd include it because it's nice to have long videos. Thanks for tuning in. This will be on iLearn.